I am Venkat Durga Kiran, working for SRKR Engineering College in Department of CSE. So today we will see the introduction of machine learning and learning outcomes of machine learning and other objectives of the course. So after this course, you will get to know the well-known supervised, unsupervised machine learning algorithms, understand the concepts of artificial neural networks and reinforcement learning, able to apply some basic machine learning algorithms to real-world problems, identify the metrics used to evaluate the models you have done in machine learning. Machine learning is a systematic study of algorithms and systems that improve their knowledge or performance with experience. Machine learning allows machines to learn and infer from the data. So these are the basic and important machine learning applications which we use and also see in day-to-day lives. Email spam filtering, web search, self-driving cars, predicting the spread of disease, and identifying who is at most risk of getting disease, recommending products, books in sites like Amazon. Also, if you find movies recommendation in Netflix, music similarly, and you are using this personal assistant in your mobiles, in Apple Siri or Microsoft Cortana or Google, vehicle driver assistance, fraud detection, web advertisements, speech recognition, predicting house prices, stock prices, etc., and natural language processing, sentiment analysis with Twitter data, and so and so. And we can also do language translation, summarizing large text documents, chatbots, which we automatically use to chart in some web applications, generating poetry and music, image caption generation, video subtitles generation, plant weed and disease detection, handwriting recognition, targeted marketing, weather prediction, face detection, mood detection, logo detection, and in games. So these are some important machine learning models which we used to see in day-to-day life, and I think you get to know when I am just reading and going through these titles of these applications. So these are the different tasks in machine learning. Based on the task, we would need to choose the algorithm. So coming, if I am coming from downwards, so if my task is to say whether this particular person is having some disease or not, so it's a class, you are classifying whether that person is having the disease or not. It's a classification task. So generally you will be knowing some important biomarkers or important features in the data which will help the machine learning algorithm to diagnose the disease. So that's because now you are knowing some parameters or the features in the data. So you are supervising the algorithm, then it's a supervised learning algorithm. So if the data is unstructured, where you don't have the columns of the data, and the data you cannot identify some features or important columns in the data, then it's unsupervised data, where these tasks will come under clustering and dimensionality detection. And there is other one, reinforcement learning, which the model will train and iterate itself until it will find the best possible outcome. So genetic algorithm is a kind of reinforcement learning where it will iterate and identify the best solution out of the possible solutions. So these are the different algorithms: linear regression, decision trees, neural network, ensemble models. All these are different algorithms in regression. Similarly, we have different classification algorithms, clustering algorithms, and dimensional reduction algorithms. So whatever algorithm or whatever type of task we are doing, this is a generic overview of how a machine learning model will be looking like, or how it is applied. So basically, domain data we will be having, some whatever the domain it may be, it will be fetching some features in the data. We are applying an algorithm on the data. In the that algorithm will fetch the features and train. It will get trained. What we will do is we will divide the data into training and testing. For example, we have 100% of data. For training, we will be dividing into 80%. With that 80% data, this model will get experienced, means that will get trained. So once the training is done, it will give the output, and we will identify how much percentage of output is result, which is accuracy. So based on the accuracy, we will decide which algorithm is better fitting this data. So in classification, if we consider the example which we have taken, like whether that particular person is having the disease or not, we are having a different state of art algorithms. So we can try different algorithms and finally choose the algorithm which is giving the best accuracy, for example. So after training, we will see the accuracy, and then we will just apply the test data. So test data will not have the output column, whereas trained data will be having both input and output columns. So we will just feed the test data where there is no output. Then we will identify the accuracy, how the model is working. So based on that, we will finally implement or deploy or apply this model in the applications we are doing. So this is how a brief overview of how machine learning will be applied and implemented. So coming into the supervised model, as discussed, supervised, we will be giving some features as well as inputs along with the output to train the model. So that's why it's input output pairs, where it will get experience based on that, and it will give the results to data which is not having the output based on the experience as well as the similarity it look for in the existing training data it has. So that is how it gives the outcome. It's a supervised learning type. Unsupervised, as discussed, is a unstructured, where you cannot give input and output, where machine will just train itself on the given algorithm, based on given algorithm, and then it gives the output. So you can apply different unsupervised algorithm on the training dataset, and finally take the best model which is giving the best accuracy. Reinforcement learning, as we discussed, it iterates with all the possibilities it have to give as output, and the best possible outcomes, I mean the right ones will be getting a reward, and the wrong predictions will not get any reward. So finally, the more reward the solution is having, it will be selected as a final solution in reinforcement learning. That will be giving as the final solution which is having the most outcome, or the final prediction which is having most rewards, will be given as output in the reinforcement learning. Here also the machine will learn and train by itself without any inputs from the user or a developer. So coming to the clustering, the clustering part, sorry, I missed it here, reinforcement learning, and then this is an overview of classification. So in classification, it will just divide the group either yes or no, true or false. It's diagnosed with a disease or not diagnosed with a disease. It separates the group, which is overview of classification here. So different applications of classification, or it will predict it's a male or female based on the data is given, spam email or not spam email, author of a book, positive or negative, and true or false, yes or no. So all these are coming into binary classification. So coming to the multi-class classification, more than two kind of classes, we will be classifying the different types of soil, types of crops, classification of mood, it could be emotions, feelings, songs, and music. Regression, as you see in the image, it's a kind of continuous values or real values. If you just consider a weather report or the share market, so it will be constantly changing, which will continuous which will be a continuous value. So in that scenarios, we will be using the regression algorithms. So the regression algorithm will fit a line that based on the existing data available, it will just fit the best fit, which gives the approximate values. So for example, on the day one, the weather is it will be like this. On the day two, the weather will be approximately like this. So these kind of continuous or real values will be applying regression algorithms. So the application of regression algorithm or engine performance, studying engine performance and test data in automobiles. It can be used for causal relationship between parameters in biological systems. Regression can be used in weather data, can be used in market research studies, which is share market or customer survey results analysis. So these are different types of regression algorithm. And coming to the clustering, so if you just see the figure, you will be understanding the data is got divided into groups. So let us just consider telephone service data, where in a city there are different people will be using different plans. So if we get the having the information of, for example, people and the usage of plan, it will cluster them into the groups, and the telephone service provider can just identify which kind of customers or which range of income people are using some plan, or which kind of customers, students are using some other plan, or corporate people are using some other plan, and so on and so forth. So that's how they will get to know like which plans will be working best for the business to attract customers and allow customers choose the best plan that works for them. So that is how the clustering algorithms will be useful. So applications of clustering is marketing, which we just discussed now, and biology. It can just classify the different kinds of plant images, animals. Not only images. If you apply this clustering algorithm, it will just identify different kind of plant species, animals based on the application. And then the library is clustering different books on the basis of topics and information. Insurance also they can do like similar to like telephone service, where based on the age and income they can plan different kind of insurance policies, and also they can identify the fraud. So these are the different kind of applications we can utilize through clustering. And reinforcement learning, overview how it's get applied. So firstly, input is defined to be the initial state from which the model will get start. It's a basic for every model. And the output of reinforcement learning will be like from many possible outputs, from variety of solutions for a particular task. So these are the different possibilities of outcome and variety of solutions for any problem. So the training will be based upon the input provided. In return, the model returns a state, and then it is the user's decision to decide whether if the outcome is needs to be rewarded or punished. So based on that, the model keeps learning, and the maximum award determines the best solution, which is the final outcome of the reinforcement learning algorithms. So these are the basic steps involved in designing a machine learning system or a model. So choosing the training experience, like we need to choose how much percentage of data we would like to give for machine to get the training experience. And we need to choose the right target function, which is nothing but like choosing what kind of data it is, and for this kind of data which kind of task we need to go for, which kind of function we need to use. So that kind of idea we need to have, and choosing a representation for the target function. So we need to represent some, if we know some domain data, or if it is a supervised, we need to represent some columns as input for the target function. And we need to find out the best algorithm out of the algorithms we have in whatever task we are choosing. And based on the best performance algorithm, after applying different algorithms on kind of data set, we will be finally designing the best model which is giving good accuracy. So that is all about the basic introduction of machine learning, and thank you one and all.